Hello friends, myself Professor G.P. Bhagat from Department of Electronics, KBP College, Pandharpur. In this third lecture of electronics of Unit 1, Architecture of Microcontroller, and from paper number 10, that is Fundamentals of Microcontroller, we are going to cover the various points such as memory of 8051 microcontroller, then memory organization, then various GPRs and SFRs of 8051 microcontroller. Let us see first memory of 8051 microcontroller. The 8051 has separate internal memory space for code and data. The code memory is also called as ROM and it is used to store the programs. The size of that internal ROM is 4 KB. Then the data memory is also called as RAM and it is used to store the data. The size of internal RAM is 128 bytes in this 8051 microcontroller. Let us see ROM in detail. 8051 has ROM of size 4 KB like this. Then this 4 KB of ROM address from 0000H to 0FFFH. This is the internal memory of internal ROM to the controller, but for this to the controller we can connect external 60 KB of ROM from address 1000H to FFFFH. This is the external memory which can be interfaced to the controller. Therefore, total ROM that can be available for the 8051 microcontroller becomes 64 KB. That is, total ROM for 8051 becomes 64 KB. This memory can be accessed, that is internal as well as external, if EA, that is enable access, external access pin is equal to 1. Then if this pin is at 0 or if this pin is connected at ground, then this internal 4 KB of ROM cannot be used or it can be avoided, and total 64 KB of ROM can be connected externally and that can be used from the address 0000H to FFFFH. This total ROM of 64 KB becomes external. That is, in this case, internal 4 KB ROM will be disabled. The next, let us see about internal RAM in 8051. The size of internal RAM is 128 bytes. This 128 bytes is totally internal RAM of 8051, which can be addressed from 00H to 7FH. That is, these are the total 128 bytes. Then above 7F, that is from address 80 to FF, there are 128 bytes which are assigned or which are used as SFRs. Let us see the structure of internal RAM. This internal RAM is divided into various parts ranging from 00 to 7FH. Here at address 00 there is one register bank, that is bank 0, ranging from address 00H to 07H. This register bank is actually a group of 8 registers, as from register 0, register R0 at address 00, register R1 at address 01, register R2 at address 02, like this up to the register R7 at address 07. These are the 8 registers that are available in one bank, that is bank 0. This bank 0 consists of total 8 registers from R0 to R7, ranging from address 00 to 07. These registers R0 to R7 are called general purpose registers, which can be used in program for general applications. The next, there is another bank, that is bank 1. This bank ranges from 08 to 0FH. Also, for this bank there are 8 registers as like bank 0, and these registers are ranging from R0, these registers becomes R0 to R7, same as that of the register bank 0. Then next there is third bank, that is bank 2. This bank ranges from address 10H to 17H. This bank also consists of total 8 registers as like bank 0 or bank 1. The next there is fourth bank, that is bank 3. This bank have address from 18H to 1F. Again this bank also consists of 8 registers or general purpose registers as like bank 0, 1 or 2, and names of these registers are register R0 to register R7. There is for all the banks the names of the registers are same, that is R0 to R7, but address of each register for different bank are different. These are the 4 register banks, that is there are total 32 bytes which are used for register banks. The next there are 16 bytes that are used as bit addressable RAM, that is here these 16 bytes are bit addressable, that is a single bit from any byte can be accessed individually by using some different instructions. And for this bit addressable RAM, the address range is from 00 to 7F, that is there are total 128 bits that can be addressed, or that is these bits which belongs to bit addressable RAM are accessed individually by using separate instructions. These are only 16 bytes which can be bit addressable. The next there are another there is next block or next locations of RAM, and these locations are total 8 bytes, or there are total 80 bytes of RAM that can be used as general purpose RAM, and this general purpose RAM is assigned from address 30H to 7FH. There is these are the 80 locations or 80 bytes that can be used as general purpose RAM in the 8051 microcontroller. The next, let us see SFRs in 8051. SFR means the special function registers. There are total 21 SFRs in this 8051 microcontroller. As we seen in previous slide, there is 128 bytes of RAM. Above this 128 bytes, there is another block of SFRs ranges from address 80 to FF. Let us see in detail about SFRs. These SFRs are ranging from 80H to FFH. Let us see the SFRs in detail. First, at address 80 there is port 0, that is this byte having address 80 is assigned for port 0, that is P0, and this port is bit addressable as there is a symbol of star near address 80, that is this star indicates it is the bit addressable SFR. The next, at the address of 81H there is another SFR, that is SP. SP stands for stack pointer. The next, there is another SFR at address 82, that is DPL. Here at the address 82 and 83H, these 2 bytes are for data pointer register, but data pointer is divided into 2 8-bit registers, that is DPH and DPL. The next, there is another SFR, that is PCON, power control register, having address 87H. The next, address 90 assigned for port 1, that is P1. Again this P1 is bit addressable as star is given there. The next SFR is SCON. Again this SCON is also bit addressable at address 98H. The next SBUF having address 99H. There is like this, there are various SFRs as port 2, then IE, then port 3, PSW, accumulator, then register B, like this. But these SFRs are not having the addresses in proper sequence, because in between some of the bytes are kept blank. Therefore there is no proper sequence of the addresses if we see carefully this map of the SFRs. At address FF, that is at last address of this block, that byte is blank, that is it is not used for any SFR. The next, let us see PSW, that is program status word of the 8051. This PSW has the address of D0H and size of the PSW is 8 bit. Let us see the structure of PSW, program status word. This PSW consists of total 8 bits. Let us see each bit one by one. First, that is MSB of this PSW is used for carry flag. That is this PSW is used for various carries. This MSB of PSW is used for carry flag. Here carry flag will set when any carry or borrow will be produced in the result, otherwise it will be reset. The next, second MSB or PSW 6 bit of PSW is assigned for auxiliary carry. Auxiliary carry means here auxiliary carry will set or it will be produced in lower nibble of the result. That is, if in the lower nibble of the result carry is produced, then this auxiliary carry bit will be set. The next bit is F0. F0 is general purpose flag for user programming. The next, there are two bits RS1 and RS0. These two bits are used for register bank selection. As per the table given below, these banks will be selected. If RS1 and RS0 both are 0, then register bank 0 will be selected. Then if RS1 is 0 and RS0 is 1, then bank 1 will be selected. Similarly, if RS1 is 1 and RS0 is 0, then bank 2 will be selected. And if both the bits, that is RS1 and RS0 are 1, then bank 3 will be selected. But here by default bank 0 is selected. That is, if we do not change the RS1 and RS0 bit, then by default it will select the bank 0. The next bit, that is PSW2, it is overflow flag denoted by OV. Overflow means this bit will be set or this flag will be set when overflow is produced in the result. That is, in suppose in signed binary number there are only 7 bits for magnitude, but if these 7 bits are insufficient to store the result, then it will produce the carry, and that number will not be fixed in that 7-bit size. Therefore, in this situation, it will produce or it will set the overflow flag. The next bit, that is PSW1, this bit is reserved for future use. That is, it is not used for any purpose till now. The next last bit, that is LSB of the PSW, is for parity flag. This parity flag will be set for odd parity. That is, if in the result number of ones are odd, then this parity flag will be set. This is all about the PSW and various flags of 8051 microcontroller. The next, let us see stack pointer in 8051. Stack pointer have the address of 81H and its size is 8 bit. The section of RAM used by the CPU to store the information temporarily is nothing but the stack. That is, this stack is having the default address 07 in internal RAM. That is, by default address of the stack in RAM is 07. Let us see how the data can be stored in the stack. That is, this stack is the location in RAM which is used to store the data temporarily as per user's need. Let us see how data can be stored on the stack. Initially, stack is having the address of 07. Then for the storing of data on stack, the style is increment the stack and then store. That is, if we have to store the data on stack, then stack pointer is initially increased by 1. That is, here stack pointer from 07 to increases from 07 to 08, and then at this address data will be stored. Similarly, for next byte, if we have to store another byte, then initially stack pointer is increased first from 08 to 09, and after this increment data will be stored to the address 09. Similarly, for third byte, stack pointer is first increased by 1 from 09 to 0A, and then data will be stored to the address 0A. Similarly, if we have to remove the data from stack, then the style is opposite to that of storing process, that is, first remove the data and then decrement the stack, that is get then decrement. Here at first data will be removed from stack and then stack pointer will be decreased by 1, like this. Similarly, if we have to remove next one byte, then at first data will be removed and then stack pointer will be decreased by 1 from 09 to 08. Similarly, if we have to remove the data from the address 08, then initially data will be removed and then stack pointer will be decreased by 1. That is, stack pointer becomes decreased from 08 to 07. That is, in this way or in this style, that is get then decrement, the data will be removed from the stack. Then next, let us see the data pointer. Data pointer is one of the 16-bit register which is used to store the external code or external data memory. This data pointer is divided into two parts, that is DPH and DPL. Both the DPH and DPL are of 8-bit in size, like this. DPH 8-bit and address of the DPH is 83H. Then next, another part of the DPTR becomes DPL having 8-bit size. Address of the DPL is 82H. Then next, let us see program counter of 8051. It is the 16-bit register denoted as PC, and it is used to give proper sequence to the program. It always contains the memory address of the next instruction to be executed. The next SFR, that is accumulator. Accumulator is one of the most versatile 8-bit register that is used to hold the result of various arithmetic as well as logic operations. The address of accumulator is E0H. This accumulator is having the size of 8-bit. The next, register B. Here register B is one of the 8-bit SFR that is used in only two instructions, that is instruction of multiplication, that is MUL, and instruction of division, that is DIV. The address of register B is F0H. This is register B having the size of 8-bit. These are the various SFRs in 8051. So thank you very much.